All right, time for the very special case of work and circular motion. This one I want to make sure that everyone understands because it is a great question and very much gets at, do you understand the idea behind this whole thing? So a small box whose mass is 0.044 kilograms sits on a turntable, i.e. a record player, at a distance of 0.12 centimeters from the center, and you can see the overhead view here. The box moves with a constant speed of 2 meters per second. All right, assume the box makes exactly 1.25 revolutions, so it goes around 1.25 times. Now, things to keep in mind that might be helpful here. If you remember that the velocity is always tangent to the path of an object moving in a circle. And in order to make it go in a circle, there needs to be a centripetal force pointing radially inward towards the center of the circle as it moves around. Now, keep in mind, we know that the velocity is constant, or the speed is constant. So, I'm going to ask you something. If the speed is constant, what does that tell you? If the speed is constant, that means that the magnitude of the velocity is going to remain the same. And since kinetic energy is 1/2 mv squared, and we don't really care about the direction, it's the magnitude that we're looking at, that means the changing kinetic energy of the system, is going to be 0. So let's take a look at this. What is the centripetal force on the box? All right, we got to go back to circular motion. And you may remember that the force centripetal is equal to MAC, which is equal to mv squared over r. In other words, it's going to be towards the center, and we got to keep that in mind. Now, I'm not going to bother punching in a bunch of numbers at this point, but I am going to get us set up so that we can kind of look at everything as we go. Next up is, what's the change in kinetic energy of the box? Well, we already pointed out that its speed stays the same. So the change in kinetic energy is going to have to be 0 joules, all right? Because the final is equal to the initial, or at least the magnitudes are. And so what is the work done on the box? The work net is going to be, pardon me, sorry about that. The work net is going to be equal to the changing kinetic energy, which means it's 0.0 joules. But using the definition of work, and what is the definition of work? The definition of work would be that work is F d cosine theta. So we drew in the velocity overhead, but remember, velocity and displacement have the same direction. And those are tangent to the path. And we also know that our centripetal force must be towards the center, which means the angle here has to be 90 degrees. In other words, the centripetal force can never do work because it is perpendicular to the displacement of the object at every point along the way.